All right, the next speaker is Petr Broz, who will talk about LUGO. So, Petr, take it away. Thanks.
Thank you. Can you just confirm that you see my screen and can you hear me, please?
Yes.
Yes.
Super. Thank you a lot. So I'm today to thank you very much of organizer for organizing this symposium. It's really nice to be here. And today I would like to speak here about the Lunar Geology Orbiter LUGO, which is a new mission which we are trying to propose to go to Moon and to make some really nice science. As you can see, this is a cooperative work with a bunch of people from different institutes across the Europe. But officially, this mission is covered by TRL Space company, which is a new startup just starting operating in the Czech Republic. So first of all, a few words about the motivation, and we will start deeply in the history. This is the image which is showing the Europe like 1980, something like that. And you can see that in this time, the Europe was divided by Iron Curtain into two blocks, the Western Europe and the Eastern Europe. Luckily for all of us, this division is gone. Unfortunately, if you would really go through the data, you can really still see that the Europe is divided, even we are united. If you would check the mean wealth per adult, you can see that the Western countries are more richer than the Eastern countries. If you would go into the number of ERC grants per country, you can see that the Western countries are much more successful than the Eastern countries, which I marked here by red dots. Of course, I'm not complaining. I know this is also my mistake that I'm not more active by asking for grants as a scientist working in the former Eastern European communistic country. But you can see, for example, that this is the same issue where we are speaking about exploration of the space. This is the map which is showing involvement of partners for ExoMars. You can see that former Eastern communistic countries are not really involved. So one of the reasons is, of course, that much larger amount of planetary scientists are living on Western countries than on the Eastern countries. But it's also partly the result that much more space industry companies are operating on Western countries than on Eastern European countries. So part of the motivation to make a LUGO mission is actually to show that the small Central European countries can do ambitious space missions if they are working together. Actually, we would like to show that these countries do not have to be only subcontractors in the big space missions or for Western countries, but that we are able also to make ambitious missions and that we can be a leader in Europe in the way of exploration of the space. At the same time, we would like to show that the industry within this region have a huge potential, because we would like to show that we are able to develop a valuable payloads, that we are able to utilize CubeSats and so on and so on. So this is a part of the motivation from the industrial point of view. However, I'm not a representative of the industry. I'm a scientist. I'm focusing about exploration of Martian, exploration of volcanoes, mainly on the surface of Mars. But this time I'm also in love with one enigma, which is on the surface of the Moon. So there is a nice scientific question we would like to try to answer, and it's nothing easier than to understand the lunar thermal evolution. How we would like to do this? I'm sure that all of you saw this image, which is showing the ages of main lunar volcanic activity. And you can see that most of the activity occurred really relatively soon after the Moon was formed. That was the radioactive element which were able to produce a heat. But with the ongoing time, the volcanism was in decline, and it's generally thought that volcanism on the Moon stopped roughly to say 1.2, 1.3 million years ago. However, there is an issue that if you would look on the surface of Moon, you can easily find that there are some really strange looking features, which are generally termed as a lunar irregular patches. Probably the most famous one is Ina, which is for me as a volcanologist, really strange feature, which is situated inside the central depression on top of likely volcanic structure. It's probably a shield volcano. We don't really know what these what this feature or many other features, because Ina is not the only one, these features are. As far as I understand, there is at least agreement that these features are volcanic in origin, but there is an enigma how these features were formed. What is interesting, when you are browsing images of these features, you would actually discover that there are only a relatively small amount of impact craters, and that these impact craters are, relatively speaking, quite small. So when you would try to use a crater chronology, crater counting, and to fit the chronology curve, you would end up with the age that these features have to be really, I don't know how much time we have, but really young. So let's say less than 100 million years, which is quite surprising, because as I said, generally we believe that the moon was not volcanically active as recently. So if this research is correct, we should probably rewrite the books about the evolution of the moon, because there has to be, at least locally, some places where there was enough heat to actually produce melting and to make a magma which was able to go to the surface and make these irregular patches. However, and there is a big however, there is interesting paper by Lionel Wilson and Jim Head, and there are some many other papers where these two authors are also co-authors, and they are saying no, that these features are really actually incredibly old, that they are like 3.5 billion years old, but they are super strange. Why? Because they are proposing that these features are actually formed by something which we can call it as a lava foam. What is it, lava foam? That should be a volcanic rock which has like 19 or 99+% of bubbles, which can be still infilled by gases. Maybe not, that's hard to actually answer. But anyway, it should be a material which is quite similar to artificial aerogel, which we are using on the spacecraft to catch high velocity targets which are flying in the space. So if Lionel Wilson and Jim Head are right, that would mean that if you have a meteorite or impactor which is hitting these features, part of the energy would be taken away by the destruction of these bubbles. So in the end, you can have much smaller impact craters than normally if these features would be formed by consolidated basaltic rocks. And that means that these features cannot be as young, they can be really old, and that means that we don't have to rewrite our books. The problem is that we don't really know where is the truth. As you can see, Ina, that's the yellow cross on the image, is not alone. There are like few dozens of these features. So it's showing us that if these are really young volcanic features, that the volcanic activity has to be spread relatively widely on the near side of the moon, which would really need some explanation. So what we are proposing is to actually make a dedicated mission which would be trying to understand the formation of these enigmatic features. We would like to go we would like to develop a small satellite mission which would be inserted into lunar orbit. The ellipse would be highly elliptical, so at the closest, the spacecraft would be flying, let's say, 10 to 20 kilometers above the surface. That's important because we would like to get on board a LiDAR and the ground penetration radar. Why? Because we would like to get the exact shape of the irregular patches, and we would like to try to reveal their inner structure by using the radar. It's reasonable to expect that you would have a different radar reflectance if these features are formed by lava foam or consolidated basaltic rocks. Then we would also like to get on board one of these instruments. We don't really know yet which one because we would be limited by a mass. But it would be nice to have some sort of instrument which would be allowing us to get information about the composition of the rocks which are forming these features, and which can tell us more. So the idea is that we would like to send the probe, and it would be orbiting the moon. However, we would not just be sending one probe. We are proposing to send two probes. one probe would actually be released from the surface, from the another orbit, or it would fly there independently. But the aim is to hit the moon, actually to make a big bada boom, because we would like to make an impact crater, a new artificial impact crater on the surface of one of these irregular Mars patches. Why? Because we would like to study this newly formed impact crater by a LiDAR, and from the shape of the crater, we would like to find out if these features are formed by consolidated basaltic rocks, or if these features are formed by lava foam. So, of course, if we, thank you. Of course, if we will be able to hit one of these irregular Mars patches, that would be quite nice, because we will be exposing rocks. We will expose rocks which can be studied there more in the future. And that's actually quite nice, because I know that there is one idea to send a rover to study irregular Mars patch, actually INA, by Ernst Hauber, which will be presented in a few minutes once I finish. So we are actually in synergy with this mission, because firstly, if we are lucky, we will be able to make a crater, and few years later, we can have a rover which will go there and which can really study this crater and study the newly exposed rocks, which will be incredibly great from geological point of view. So the roadmap, where we are now. We are now in the phase 0. We are trying to put together all the materials which we need to make a good and strong proposal which would be entered into the mission, into the post-2030 expert elements of ESATRA NOVA program for CM22. If we are lucky and we would go through and we will be voted into the phase A and B, we would like to send the probe like in 2030. So we are really at the beginning, but what I'm trying to say is that now is the best time if you would be interested about the industrial point of view, or from the industrial point of view about such mission, or from the scientific point of view about such mission. Please get in touch with us, with me, or with Petr Boháček. There are the emails, and we are happy to welcome you on board, because this is really a mission which can bring a nice science, and which can also improve the industry across the former Eastern European countries, communistic countries. Thank you a lot.
Perfect timing. Thank you, Petr. Any questions? Please put them in the chat. And while we are waiting, I wondered, are there any concerns about contamination of the site when you impact directly onto the IMP?
Yeah, we were thinking, I mean, from planetary protection, that's one question, but from the scientific, that's other one. So we were thinking to make an impactor from some simple materials which we would be aware of it. So we would be able to remove this contamination. So, but from planetary, I mean, like from the the point of view, if we are able to destroy something on the surface of Moon, that's another debate, if we should be protecting these geological phenomena or not.
I see. All right, we do have more time for questions, if there are any. Put them in the chat now. That's your chance.
Oh, maybe I can just jump into it here. That was mentioned by Ernst Hauber, when we're talking about possible foams on the Moon. So what can you say about the pumice eruptions and so on, which could explain some of the enigmatic aspects of INA?
Yeah, in principle, that's the type of the material, but you have to think that on the Moon we have almost a vacuum. So it means that all the trapped gases would expand much more. So there will be much more actually bubbles, they will be larger, and it would be really more like aerogel than the pumice. Yeah. So it would be a type of the material which we are not able to form on Earth, because the terrestrial pressure would somehow limit the ability of the bubbles to expand. So it would be quite similar, but not exactly the same.
Yeah, but that would be a direction to try to reconcile these contradictions.
Yep.
Okay.